Okay, so this week we're going to take a look at two sections, 3.1 and 4.1. 3.1 is on what's called inverse trig, and 4.1 is on right triangle trig. Okay, so this is going to help us to answer some of the questions we're going to see in section 4.1. All right, so first I'm just going to kind of describe what an inverse trig function is. Okay, anytime you do something in math, there's always a way to reverse it. Okay, it might not be easy, or could be very easy, it depends, but there's always a way to undo something. For example, if you add to something, you can always undo it by subtracting. If you multiply, you can undo it by dividing. How about if you square something? What operation undoes squaring? Yeah, square root. Okay. So last week we learned about the regular trig functions, sine, cosine, tangent, secant, cosecant, cotangent. And we learned you can type in a number and take the sign of it. So let's just... so if I type in like 30 and then press sine, I get an answer of a half. So now the question is, how would we take a half and go back to 30? Okay, how would we undo what we just did? Okay, and that's where inverse trig comes in. All right, so first I'll just show you the symbols for what they look like. Okay, inverse sine, that's kind of long to write out. So we usually don't write it out, we use the symbol. Okay, it looks like a sine with a -1 where you'd think an exponent would go. Okay, but that -1 is not an exponent. Okay, it's just in the spot where an exponent would be, which is kind of confusing. Okay, just think of it as that's just the symbol for inverse sine. Another way you might see inverse sine written is arc sine. Okay, that's an older way of writing it. Most books now don't use that, but if you do come across it, this just means this. Okay, I'm probably going to write it with the -1. Okay, and we also have inverse cosine. Okay, so your symbol for inverse cosine is cosine with a -1 where an exponent would be. Or you can write arc cosine. And the last one we're really going to look at is inverse tangent. Okay, so there's your symbol for it, or you can write it as arctan. Now I said that's the last one that we're really going to focus on a lot. What three trig functions did I mention at all here? Oh, Kyle, can you tell me one of them I didn't mention? Yeah, I didn't mention secant. What else? Yeah. Cotangent or cosecant, right? Those do have inverse trig functions. It's just that you don't really need them to do what we're going to do. In fact, you don't really need them to do anything. You can pretty much do everything with just these three. Okay, so those are the ones we'll mostly focus on in this class. Okay, any questions on those symbols? All right, so the next thing we're going to look at is when you type in inverse and then you put in a number, what do we get an answer between? Okay. Let me just type in some numbers for inverse sine, okay, and see if you can see a pattern. Okay, and I'll do it in degrees. Okay, let's try inverse sine of 0.5. Okay, I get 30. Let's try inverse sine of 0.6. Let's do inverse sine 0.8. Inverse sine of 0.9. Okay, inverse sine of 0.999. What number do you think I'm kind of avoiding here? I haven't gone bigger than. I haven't gone bigger than 1, and I'll show you why. Because I can't. So I can go up to like 0.999. And does anybody see what my answer is getting closer and closer to? 0.99999, I get 89.7. It's getting closer and closer to 90. Okay, and in fact, 90 is as high as you can go. Okay, when you do inverse sine, you'll never get an answer higher than 90. Let's try something else. Let's try negative 0.5. Yeah, I get negative 30. Negative 0.8. I get negative 53. Let's try inverse sine, negative 0.9. Negative 64. And what number do you think I can't go any lower than? And if I plug this in, I'd have a problem. Yeah, not 1, but yeah, I can't go any lower than negative 1. If I try to, I won't even get an answer back. What does it look like the lowest that I could ever go is what? The answer, yeah, negative 90. Okay, so when you do inverse sine, you'll always get an answer between negative 90 and 90. And technically, I can do negative 1, I just can't go past it. And if I do negative 1, that's where I hit negative 90. And if I do positive 1, that's where I hit positive 90. You just can't go past these two numbers. Okay. And if we look at a picture of sine, okay, we're going to spend a lot of time next week looking at pictures. But if you look at that graph, can anybody see what it looks like the highest it ever goes is? 1. Okay. And how about the lowest? Negative 1. All right, so that 1 and negative 1 that we saw earlier has some kind of connection with this graph. Okay, so there's lots of connections we'll see between what we're doing and graphs more next week. If you're doing it in radians, that's negative pi over 2 to pi over 2 radians. Okay, we could play with cosine and try to investigate and see what kind of pattern we get. But it turns out if you do the same thing we just did, you're going to get answers between 0 and 180 degrees. Okay, anytime you use inverse cosine, your answer will always be between 0 and 180. And inverse tangent, if you type that in on your calculator and evaluate it, you'll always get an answer on the calculator between negative 90 and 90. But what's the difference between what you get for inverse tangent and what you get for inverse sine? They're very close, but they're not quite the same. Eric?
It's not in degrees.
Oh, thank you. That's just my bad labeling. But yes, they should be in degrees. What else is different? Yeah?
One can be equal to 90, but the other can't.
Right. When you type inverse tangent in on your calculator, you'll never actually get an answer of 90. With inverse sine, you can. Okay, but with inverse tangent, it'll never hit 90. It's always less than 90. And same with negative 90. It'll never actually hit it. It'll always be just a little bigger. Okay, any questions on that? And there's more connections with the graphs I could show you, but we'll see that more next week. So what do you notice about all of these things? All these things I'm circling would represent the size of what? These two. Yeah, those all represent the size of an angle. You don't measure anything else in degrees, at least what we study, except angles. Okay? So that should give you a hint at what inverse cosine, or inverse sine, or inverse tangent does. The answer that you get back is always an angle. Okay, so a lot of times what we do is we use inverse trig anytime we need to find an angle. Okay, that's what it's used for. So when we do section 4.1 where we're solving right triangles, if we know a couple sides in a triangle, like let's say just a simple Pythagorean triple triangle, I could find that angle or that angle using inverse trig. Okay? That's how I would do it. And they don't come out to nice answers. I know the sides are nice numbers, but the angles come out very messy. So I'm not going to do it today. Okay? But that's what inverse trig is used for. Okay. Any questions on that? All right, so we already kind of talked about where that negative 1 to 1 comes from, how you can't plug in. Let's see if I go back here, like for inverse sine. I can't plug in something bigger than 1. If I try, it doesn't work. Okay? So now I'm going to take a look at why do we get answers between negative 90 and positive 90? I mean, why for inverse sine, why can't I get an answer of like 103? Why does it stop at 90? Okay. So we're going to make a table, and we're going to write out these 5 values. Okay, so I've got angles, and then I'm going to take the sine of them. Okay, so let me start with just the regular sine of 30 degrees. And I get 1/2, or 0.5. Okay, I'm going to do the sine of 65. Okay, and I get, we'll call it 0.91. Okay, the sine of 90. Does anyone remember what that one's going to come out to? Well, it's pi over 2 in degrees, but when I typed, anyone remember what I typed and that came up as the answer earlier? 90? One. Okay, remember when I did inverse sine of 1, I got an answer of 90. Now when I take the sine of 90, I get an answer of 1. Right, so that was taking the sine. So if I ask you for the sine of 65, it was 0.91. Sine of 90 is 1. Now, let's just say this in reverse. Sam, what if I took the inverse sine of 0.91? What would I get? I would go back to 65 degrees. Okay, John, what if I took the inverse sine of 1? I get 90. Okay, there's no question. 0.91 goes back to 65. 1 goes back to 90. Let's do this last one, and then you're going to see a problem. Okay, let me take the sine of 150. What do I get? I get 0.5 or 1/2. Now if I asked you, what's the inverse sine of a half? What's the problem here? It's what? Could be 30. Or based on this table, what else could it be? Could be 150. Okay, when you're trying to go from the right column back to the left, the problem is you can't have more than one answer. Okay, and right now I could say, well, could go back to 150, or it could go back to 30. There's 2 that came out the same. So what we do is we limit it so that can never happen. All right, if we stick to saying, okay, we're only going to look at answers between negative 90 and 90, what that does is it automatically eliminates that second answer, and we don't have to worry about it. Okay? If we didn't limit things the way I just showed you on this page, what would happen is people could get multiple answers for these questions. Okay? And we don't want that to happen. Okay? Basically, what you want is just to get everybody to get one answer and the same answer to the problem. All right. So I'm not going to go through it for sine and cosine and tangent, but that's the basic idea. If you stick with these limits, the second answer will always cross itself out, and you'll just get the one answer that we want. Okay. The way that we're limiting these is exactly the same way that a calculator does it. Okay. If you type in inverse sine of a half on your calculator, it will not give you 150. It will give you the answer we want, which is 30. Okay. So any questions why we have to put these limits? Okay, so we all just get one answer to the problem. All right. Okay, so just to kind of compare it to what we did last week, inverse trig is basically exactly the opposite. Okay, last week, this is what you did. This was last week. Okay, what I did is I gave you an angle. Like, think of the last 5 questions on the test. One of them was, just pick one out, sine of 82. I gave you the angle, and I told you to find the sine of it. Okay, that's what you did last week. Okay, this week, let's figure out what that comes out to. Sine of 82 is, it's about 0.99. All right, so this week, what I would do is I would give you the 0.99, and I would say, what angle would I take the sine of and get 0.99 as the answer? Okay, so that's the difference this week. I'll give you the answer, and you tell me what the angle would be. And the way we're going to do it is inverse sine. Or inverse cosine or inverse tangent. Okay, so any question on how this is different from last week? All right. So there are some angles that are going to come out to answers that we're very familiar with. Okay, if you look at this table, what kind of angles are listed in the table that I just passed out? Okay, let me just put up the table so you can kind of see it. What kind of angles are in this table?
Multiples of 30 and 45.
Yeah, they're all multiples of 30 and 45. Okay, you won't find angles that are not multiples of 30 or 45 in this table. Okay, so if the angle that you're working with is a multiple of 30 or 45, okay, then we're going to use this chart to figure it out. Okay, but you might say, well, how do I know what the angle is going to be? Because that's the question I'm going to ask you. I'm going to ask you, what is the angle? So it's almost like saying you need to know the answer to the question before you figure it out. Well, the way you can kind of know if it's going to be an answer that's a multiple of 30 or a 45 is look for questions that have these kind of numbers in them. Okay, 1/2, negative 1/2, okay, root 3 over 2, root 3, root 2 over 2. Any of the numbers, any of the square roots that you worked with last week. Okay, those are the kinds of numbers you want to look for, and that's a hint to use this table. Okay? So, as an example, if I ask you for the inverse sine of 1, okay, 1, negative 1, 0, those are all arguments we worked with on the unit circle. Okay, so ask yourself, is the argument, okay, that's the argument, the thing right here. Is that thing one of the numbers we worked with last week? Okay, so most of the time, square roots of 3s, square roots of 2s. Yep, those are all numbers we worked with last week. All right, so first thing is I'm looking at that example. I see my argument's a 1. And I'm thinking, is that something I did last week in unit circle trig? Yep, I had coordinates that had 1s in them. So I'm going to look on this table. And what I'm going to do is go down the sine column till I find a 1. Okay, once I find a 1 in that column, then I'm going to go over and I'm going to look at the angle. And that's my answer. Okay, so you're looking at this table to tell me an angle for the answer. Okay, so if you go down the sine column, where do you find a 1? Across from what angle? Yeah, across from 90. Okay, and that's all we have to do. Now, sometimes you're going to see more than one answer. Okay, if I keep going down the sine column, I don't see the number 1 ever repeat. Okay, so that one's okay. There is only one answer to pick. If there's 2 answers to pick, remember what we said. You need to pick the one between negative 90 and positive 90 for inverse sine. Okay, cosine is different, but inverse sine is negative 90 to 90. All right, so let's try inverse sine of negative 1. Okay, anybody tell me where you see that one? And just be careful about how you say the answer, because it's got to be between negative 90 and positive 90.
170 degrees.
Where do you see it, John?
270.
Okay, I agree. It is in the row for 270, but can I write 270 as my answer? No, what's 270 the same as?
Negative 90.
Negative 90. And that's what we have to write. Okay, and you could, this is actually one you could do on the calculator. If you type it in, and then I press inverse sine. You know what, let me do it on this one. I like this calculator better because you type it in the order you see it in the problem. If you use this calculator, you have to type it in the reverse order. So I have to start with what's in the middle and then work backwards. It's kind of confusing. So let's stick with this one. Second, inverse sine, negative 1. Okay, so it's not going to say 270 because that's not the answer we want. It is going to give us the negative 90. Okay, how about inverse sine of 1/2? And this time I think we're going to see it possibly a couple times. So let's write down both answers and then cross out the one that we don't want. Okay, just to make sure everybody sees both answers. Sam, can you just give me one of them?
30 degrees.
Yep. If you look at 30 degrees, you're going to see it there. And does anybody see where else it occurs? Shakira? It also occurs at 150. And of course, 150 is the same as negative 210. I'm not going to write that. And 30 is the same as negative 330. Okay. Which one of these answers is the one we want? Yeah, we want the 30. Okay. We always have to pick the one between negative 90 and positive 90. Now, what if they didn't want the answer in degrees? What would 30 degrees be in radians? Connor? Yeah, pi over 6. Pi over 6. Okay, next one. This time I'm not going to write it down if we see more than one answer that works. We'll say both of them, and then I'll ask you which is the one that we want. Okay, so how about Eric? Can you tell me what angle would be the answer to inverse sine root 2 over 2? Or actually, you know what? Just give me one of the angles, because there's a couple. Yeah, 45 is one of the answers. And does anyone see the other answer? Alyssa?
135.
135. So both of those are the answer, but we have to pick the one that's between, what, two numbers? 90 and negative 90. Okay, so which one do we want here? The 45. Yep. Okay, let's try, we'll try one more with inverse sine, and then we'll move on to inverse cosine and inverse tangent. All right, so the next one is inverse sine of negative root 3 over 2. Okay, and make sure you see that negative, because if you do positive root 3 over 2, it's going to be a different answer. Okay, so if you look at the table, you're probably going to see it in two different rows. You're going to see it as a positive angle. You're going to see it as a negative. So out of the four answers that you're going to see, two positive and two negative, only one is correct. Okay, anyone think they see the answer to inverse sine negative root 3 over 2? Yep, Connor?
Would it be 60 degrees?
If the negative wasn't there, it would be 60. But that negative is going to change it. So we're going to have to keep looking somewhere else. Yep. Negative 60, yes. Now, Kyle, the positive of that is 300. Why didn't you say 300?
So it's not between 90 and negative 90.
Yeah, it's not in between negative 90 and 90. And you can look the answer up a lot faster on that table than I can probably type it in. So let me just double check it. Oops. Divided by 2. Just going to see. And the calculator gives us the correct answer. Okay, so on a test, what I might do is ask you for both and then say which one is the one that is correct. Okay, so the calculator won't give you the other one, only this chart will. Okay, so any questions on using that chart? No? Okay, so let's try using it for inverse cosine. Okay, so this one, they're looking for inverse cosine of 0. Okay, so basically what they're asking here is this. The cosine of what angle would give me an answer of 0? You're finding the question mark. Cosine of what answer would give me 0? Okay, and Nick, what do we have to be between now? Because we're not negative 90 to 90 anymore.
0, 180.
Good. So now we got to be between 0 and 180. Okay. Well, Jared, do you see what the answer would be to this one?
I believe so.
Okay, what do you think so?
90 degrees.
90 degrees, let's check. Cosine, I'm going to go down till I hit 0. He said 90. Is that between 0 and 180? Yep, that's correct. Okay, if we keep going, you might see 0 in other spots. But if you've already found the answer that's correct, why keep looking for another answer? It's not going to be between 0 and 180. Okay, so any questions on that? So that's the angle that if you took the cosine of it, you would get 0 as the answer. Okay, now inverse cosine of negative 1/2. Okay, or another way to say it is what angle do you take the cosine of and get this as the answer? Okay, so I'm looking in that cosine column till I find the angle. And then I got to make sure it's between what it needs to be. Okay, so Shannon, do you see what the answer is to this one?
120 degrees.
120. So if we go down, let's see, that one's on the front. Yep. Now, why didn't you say negative 240? Because that's also listed there.
That's not between 0 and 180.
That's not between 0 and 180. Good. And Shannon, what if they wanted that in radians?
Pi over 2? Oh no, 2 pi over 3.
That's 2 pi over 3 radians. Both answers are correct. Just look at the directions and see what units they want. All right, so this will be our last one for cosine. If anyone needs me to do another one, I can, but it's pretty much the same. Okay, inverse cosine negative root 2 over 2. Okay, how about Brian? You see what angle I would take the cosine of and get that as the answer?
135.
Yep, 135. Which is the same as negative 225, but you don't want that. It's not between 0 and 180. And if you look on the back, you'll see it again at 315, right? Which is the same as negative 45. You don't want that either. Okay. Any questions on inverse cosine? All right, so we'll try a couple with inverse tangent. And these will be the last two we do on this chart. So take a minute and just try to find out those two yourself. Inverse tangent of square root 3 and inverse tangent of negative square root 3 over 3. Okay, first one. Inverse tangent of root 3. Okay, how about Nolan? What would you get for that one? 60. Okay, anyone else get 60? Yeah, 60. Just to kind of remind us, what do we have to be between again? We're not 0 to 180 anymore. What are we back to? Yeah, we're back to the negative 90 to 90, but will we ever actually equal them? No. In fact, if you look at your chart, look at what happens if you try to do tangent of 90. Okay, it says it's undefined. Tangent will never equal 90. All right, and the last one. How about inverse tangent negative root 3 over 3? Shakira? Negative 30. So that one's on the back, almost at the bottom. Yeah, looks good. Okay, so the table, that's great if you're working with angles that are on the unit circle that we did last week. But sometimes you're going to have an angle that it's just not a 30 multiple of 30 or 45. Okay, so that's when we're going to use our calculator. Okay, you can try to use the table, but if you look at 0.65, was that a number that we ever used when we did coordinates last week, 0.65? No. We used square roots of 3s, we used square roots of 2s, halves, 1s, 0s. The negative of everything I just said. But we never used 0.65. So you can look in the sign column for 0.65, but you're not going to find it. Okay, so we use our calculator. Right, so just to be clear what this is just a number. Okay, it has no label. It's just a number. The answer that I get is going to have a label. That'll be my angle. Okay? And that's what I'm going to figure out. Right, so I'm going to do inverse sine. Second, inverse sine of 0.65. If you're in degrees, that's about 40.54 degrees. If you're in radians, you just type in the same thing. You don't have to change anything other than your mode. About 0.71 radians. Do I need to put RAD on that? No, but I do need to put the degree symbol on that. Okay, and last week, this is how I would have written the question. Find the sine of 40.54 degrees. Now, this is your angle. And what you get on the other side, that was just your number. Yep. This was how you did it last week. And that's this week. Okay, so it's exactly the opposite. So what is that? 0.65. Okay, I'm not going to do this week and last week for every problem. I'm just showing you how it would compare. Okay. Okay, let's try inverse cosine of negative 0.24 and just do it in degrees. Okay, we don't need to do it in both. And Jake, did you get an answer for that?
103.8.
103.8. Yep, I got the same. Well, actually, no, 0.9. We round up. But I thought we had to be between negative 90 and 90. So what happened?
Cosine,
So what about cosine?
you can be between 0 and 180.
Right, this is 0 to 180. So it's 103.89 degrees. Okay, and the last one, we'll do inverse tangent of 34.3. Okay, is this 34.3 radian or a degree? What? Well, it is something.
It's ready.
It's just a number. It's neither. Okay, that's not a radian or a degree. Trick question. 34.3 is just a number. The answer that you're about to tell me, now you could be in radians or degrees. I'm going to do it in degrees. Anyone think they got an answer for inverse tangent 34.3? Yep, Sam?
88.33.
88.33. Perfect. Okay. Biggest mistake I usually see on these kind of problems is, let's say you had these as choices on the test. 34.3, 88.33, and let's put that one in degrees, and then something like, let me get the answer in radians. 1.54, and I'm going to write degrees as a choice. Okay, which answer is correct there? B. Okay. Which answer is correct now? A. All right, so you got to pay attention to, are your answers in radians or are they in degrees?
Are you going to specify the questions, like if you want it in radians or degrees?
If it's not a multiple choice question, yes.
Okay.
Yep, if it's multiple choice, you just have to look at the answers and see if they're in radians or degrees. You know they're in radians if they don't have the little circles. And there's not going to be a mixture. All the choices are either going to be per problem, either all in radians or all in degrees. Okay? Maybe in the next question I'll switch to a different unit, but I'm not going to mix degrees and radians in one question. Okay? Okay, so any questions on inverse sine, inverse cosine, or inverse tangent? All right, so I said we're not going to really do a lot with inverse secant, cosecant, and cotangent. And in fact, when we get to section 4.1, we're not even going to talk about them at all. Okay, but just because we don't really need them in section 4.1, you could use them. I don't like using them because I think they're harder to use. But I am going to show you how to do inverse trig with one of these. Okay. First of all, do I have a button for inverse secant, inverse cosecant, inverse cotangent? No. Okay, just like I didn't have a button for sine or secant, cosecant, and cotangent. But does anybody remember what we had to do? And it's going to be something similar to this, but not exactly the same. Yeah? Yeah, we had to flip something. Okay? And the same idea is going to apply here. Okay? So I'm going to show you how you can figure out what y is, but I'm not going to do it this way. Okay? I've got to get rid of this secant. I got to write it using something that I have a button for, and I don't have a button for that. So when I'm done, my goal is to have a new formula for y. Okay? And I think once I show you how to do secant, you'll know how to do cosecant, and you'll know how to do inverse cotangent. All right. I'm going to start by doing this. What I'm doing is taking the secant of what's on the left and the secant of what's on the right. What do you think is going to happen if I take the secant of the inverse secant? Yeah, I said earlier that inverse trig functions cancel out regular trig functions. Okay, and that leaves me with this. Okay, now this is something I know how to work with. Okay, and somebody said it earlier. If you flip it, you get something that we have a button for. So what I'm going to do is I'm going to flip each side. Okay, what's my denominator for x right now?
1.
It's 1. So what do I get if I flip what's on the left? 1 over x. And does anybody remember what trig function you get when you flip the secant? Yes, you get the cosine. So now I don't have y by itself. I'm one step away from that. But I've rewritten the original problem now with a function I have a button for. Okay, so I flipped what's on the left, flip what's on the right. When you flip secant, you get cosine. Now the last thing is I'd like to get rid of cosine and just have y by itself. Anybody have a guess what function could cancel out regular cosine? Yep.
Inverse cosine.
Yeah. So now I'm going to undo what I did at the very first step. I'm going to take the inverse cosine of each side. I'm going to do it on the left. I'm going to do it on the right. And I want you to notice what just happened. Now I have y by itself. And okay? So to do inverse trig for something you don't have a button for on the calculator, take the argument and flip it. And then you have to think in your head, what do you get when you flip secant? Cosine. All right. And now from here, just type it in. 1 divided by 1.45. Okay, I'm in radians. Let's do it in degrees. Okay, about 46.4. Okay, the next one, we don't have to type it in. I just want to know how I would type it in. Okay, they're asking for inverse cosecant. I don't have a button for that. So what am I going to replace inverse cosecant with? Careful, not sine, but yep, the inverse sine. And it's going to be the inverse sine, not 2.6. We got to flip it. So what do we type in?
1 over 2.6.
Yep. So you just type that in, and that would be your answer. All right. And how about inverse cotangent? What can I replace that with that I have a button for on the calculator? Inverse tangent. And now, since I changed the function to something I have a button for, I also have to change the argument. Can't put in 0.35. Nick, what do I type in?
1 over 0.25.
Yep. And whatever you get, that's your answer. Okay, so that's the only tricky part about these three. You don't flip the entire thing like that. All you do is flip what's inside. Okay, any questions on that? All right, so I think that's a good place to stop for today. Okay, so you've got about 15 minutes. Okay, so please use the time to try to get started. I'll take some calculators out because if you don't have one, you need a calculator for tonight's homework. So it's 13 to 17, 19 to 20, 19, 20, 22 through 31, and 33, and that's all. Yeah, I think 22 to 31, you need a calculator for every one of those. So if you don't have one, you might want to do the calculator part in class and then save the part you need the chart for at home.